Hey guys, today we're going to look at 18.3 notes. We're going to talk about exponential growth and decay. Okay, so first let's look at a couple of graphs. Again, notation's a little off on my document. Hopefully it's good on yours. Add some parentheses. So the first thing that I want us to do is let's get a table of values. Let's construct a table of values. So just some x, y coordinates, okay? So you can do this by hand, but I would definitely suggest putting it in your calculator and looking at the table. So put in your calculator, you're gonna hit y equals, you're gonna type that equation and type it in just as such, 3 parentheses 1/2 close parenthesis to the x power, okay? Then you're going to hit second graph, top right-hand corner of your calculator. You're going to look at your table of values, okay? So we don't need a ton of values. We just need some positive values and negative values. So typically, we're going to just look at -2, -1, 0, 1, and 2 for my x values and see what those corresponding y values are. Okay, so when x is -2, y is 12. When x is -1, y is 6. X is 0, y is 3. When x is 1, y is 1.5. When x is 2, y is 0.75. Okay, so make sure that you can see those values on your calculator. So let's graph those values. We got -212, and that goes off the graph, but that's okay. -1, 6, 0, 3, 1, 1.5, and then 2.75, okay? So you can see these points will not make a line, okay? And what's happening is this graph cannot be 0, okay? The y value cannot be 0, so there's no value that we could plug in for x that would make y 0, okay? And there's also no value that we could plug in for x that would make it negative, okay? So what happens is it's going to approach the x-axis, but it'll never touch it. And again, that's x-axis, which is y equals 0. Okay, it's going to approach it, but it'll never touch it. That's an asymptote. So the graph is going to curve down. It's going to flatten out as it gets closer and closer and closer to that x-axis, but it will never touch it. Okay, so as we look at this graph, what's happening? So what happens to the function y value as the value of x increases. So as the graph is going to the right, it's going down. So as x is increasing, y decreases. Okay, as x is increasing, y is decreasing. All right, let's look at another one. Okay. So this one we have y equals 3 times 2 to the x power. And I want you to do the same thing. To put that in your calculator and y equals. And go ahead and graph it. We want to look at our table, second graph. And I just want to look at the same values for x. So -2, -1, 0, 1, and 2. Get some negative values. Always get 0 in there if we can. Get some positive values. And let's write down what those values are. So when x is -2, y is 0.75. When x is -1, y is 1.5. When x is 0, y is 3. When x is 1, y is 6. When x is 2, y is 12. Okay, so let's graph those. So we have -2.75. Yes, it's a decimal. You can still graph it. X is -1, y is 1.5. X is 0, y is 3. When x is 1, y is 6. And when x is 2, y is 12. Okay, so again, we're going to have an asymptote at y equals 0, the x-axis. We won't touch the x-axis. And notice the curve is going in a different direction. So here is what our curve looks like. So what happens as x increases? Well, y increases also. Okay, as it's going from left to right, the graph is going up. Okay, going from left to right, the graph is going up. Okay, all right. Let's look at some content here. Okay, so this is what's called an exponential function. I'm sure you've heard the term exponential. You dealt with them in Algebra 1. Probably heard the term exponential growth. I hear that all the time on TV, news, even in TV shows. Okay, in the exponential form, y equals a times b to the x. If b is between 0 and 1, okay, so a decimal, a fraction, any value between 0 and 1, y decreases as the value of x increases. And the graph represents a model of exponential decay. It's going down. It's called exponential decay. In general, the graph will decrease, so it will go down. It will be called exponential decay. All right. The converse of that is in the exponential function y equals ab to the x. If b is greater than 1, if b is greater than 1, the value of y increases as the value of x increases. And the graph represents a model of exponential growth. It is growing. Okay, it's growing. All right. Now I want us to just talk a little bit more about this form before we continue. All right. So we have the form y equals ab to the x power. Okay. A is, for lack of a better term, like our initial value or our starting point. Typically it's going to be our y-intercept. Okay. B is what's called our growth or decay factor. Okay, factor is another word for a number that you're multiplying by. So how much is our function growing or decaying? How much is it being multiplied by? And remember, if your b value is larger than 1, then it's growing. If your b value is between 0 and 1, then it is decaying. Okay, and it won't be negative. All right, it won't be negative. So it's just a simple way to remember what a and b represent. All right, so let's look at a few examples, and we're just going to classify. I lost my notes. We're going to classify a and b value and then name the function, whether it's a growth function or a decay function. Okay, all right, so let's look at the first one, a. It says y equals 5 to the x power. What's our a value? Well, even though you don't see it, there's a 1 there. Okay, there's a 1 there. That's our a value. It's our starting point. And our b value is 5, which is greater than 1. Therefore, it is growing. Okay, it is growing. It's exponential growth. All right. If you were to graph this, it would cross the y-axis at 1, and it would grow. It would go up from left to right. Okay, and go up from left to right. All right, b, y equals quantity 0.4 to the x power. Well, again, the a value is 1. Okay, there is still a 1 there. And my b value is 0.4. Okay, 0.4. All right. And this is what's called decay. This is decay. All right. And if you think of it as a percentage, then This one, every time x increases, y is becoming 0.4 of itself, which is 40%. Okay, it's decaying, it's getting smaller. Let's look at C. All right, we have an A value of 8, B value of 0.25, and therefore it is decaying, it's getting smaller. All right, it's getting smaller. 0.25 is less than 1, therefore it's getting smaller. Then D says for quantity 2.5 to the x power, my A value is 4. My V value is 2.5. This one's tricky. It is a decimal, but it is a decimal larger than 1. So it's becoming 2.5 times its size every single time. Therefore, it is exponential growth. It is growing, okay? It's growing. All right. Well, before we finish up, I want to look at something that I think is pretty cool. Albert Einstein said that exponential growth is one of the most remarkable things that he's ever seen. Okay, exponential growth is one of the remarkable things he's ever seen. Something grows exponentially. Okay, it's really wild stuff. So I want to look at a concept that is very interesting to me. I think you'll find it interesting too. So let's take a penny. All right, a penny. So a penny is equal to 0.01, right? So let's think about a penny. All right, so you got a penny, and you start on your 0 day, and then the first day you double that penny. So we just had a penny, and the first day we're going to double that penny, and it's going to be 2 pennies. Okay, going to be 2 pennies. Then the next day we're going to double that penny again. Okay, and be 4 pennies. All right, 4 pennies. So think about every day we're going to double that penny. Okay, so day 2 we have 4 cents. Then day 3 we're going to double it to 8 cents. Day 4, 16 cents. Okay, and continue on. And I want to know how much money you would actually have at the end of 30 days. So if I was to continue this, I get 30 days. I want to know on the 30th day, how much money are we going to have? Okay, on the 30th day, how much money are we going to have? Well, I'm going to let you guys figure that out. Okay, I'm going to let you guys figure that out. So what I want you to do is figure out how much money you would have on the 30th day, and email me what you think your answer is. And if you're right, there could be some extra credit for maybe the first couple of people that get it right. So it's kind of a fun thing to do, and do it anyway because it will blow your mind for sure. Okay, hope you guys have a great day.